Hello, this is Mr. Precella, and this is Timothy Precella, and today we're going to be looking at some applications of algebra that you've been learning. So let's go ahead and get started, and I don't guess they need to see us anymore. There. Okay, here's problem number 1 we're going to do. A projectile is launched from ground level with an initial velocity of v0 feet per second. That little v and that little subscript of 0 is read as v0, and that's standard notation for an initial value, okay? So right once this projectile is launched, it's traveling at a velocity of v0 feet per second. Neglecting air resistance, its height in feet t seconds after launch is given by, so the height in feet, so t is time in seconds, the height, that would be s, equals negative 16t squared plus v0 t. Find the times that the projectile will reach a height of 160 feet and return to the ground when v0 is equal to 112 feet per second. So let's see. Start part A. Okay, I'm going to switch there. It looks like here's the formula that gives you the height of the projectile, and t is time in seconds. Look back at the problem. It seems like we need to know an initial velocity v0. What do they tell us there in the problem? What is that initial velocity? You'll see it? 112. There it is. 112 feet per second. And then it says, find the times that the projectile will reach a height of 160 feet. So we want to know, when will the height be 160 feet? Let's switch back to the paper. So we're going to plug 160 in for S. And we have this equation to solve. Remember, v0 becomes 112. Okay, good. Okay, I've replaced the v0 with 112 and the height s with 160. And we have a quadratic equation, don't we? Yes. So let's move. We need a 0 on one side, and hopefully by now you've got the hang that I always move the a term, if the squared term is negative, I move it so it's positive. So I'm going to move all of this over here to get 16t squared plus... No, I disagree with that. Oh, yeah, you're right. Minus. I'm moving the 112. That should be a minus. 112t equals... No. Moving this over should be a plus 160. You know what? Let me write it neater. You just know it's going to be a great class when you make a mistake like that on the first problem. Minus 112t plus 160 equals 0. I think there's a common factor. I know that 16 goes evenly into 160. Does 16 go evenly into 112? I don't know. Let's see. I'm thinking it does. But I've been wrong before. So what you want to do is divide through yes. Okay, I divide through by 16. It's always good to shrink down those size of those integers. As long as you can do it without picking up fractions. Yes. So we would have a t squared minus, what did you say 112 divided by 16 was? 7. Oh, this looks a lot better. Oh, it does. I was thinking plus 10. Now, there's an equation we know how to solve. We can factor it. Let's see. That's a simple trinomial. We'll just say t times t. Second sign is plus, so 2 of the first, so it's going to be minus and minus. And what two numbers should we use to multiply together to give us a 10? A 1 times 10 or a 2 times 5?
Remember that with a simple trinomial, those numbers are going to add together to give you what?
That middle term.
That number right there is 7. 2 and 5 add together to give 7.
So set each factor equal to 0. And we get positive 2 and positive 5.
So wait a minute. That means there are two different times when the height of the object is 160 feet. Well, does that make sense? Sure it does. It's going up. And then what does it do? It comes back down.
Yeah.
So after 2 seconds, it's up to 160 feet. And after 5 seconds,
see, 2 times.
On the way up and on the way down. So hold on, let me switch over here. I need to type in the answer. Let's see, there it is. So it's after 2 seconds and 5 seconds. Notice this say use a comma to separate your answers. So
now notice there was that option, the projectile doesn't reach 160 feet. Well, if you had gotten something like negative answers,
it wouldn't make sense to have a negative length of time. So in that event,
this real projectile, there's no way it would get 1 billion feet up in the air. Okay, so it's possible not to have an answer. Now, part B,
we want to know the time it takes for the projectile to return to the ground. The projectile returns to the ground after blank seconds.
What would the height of the projectile be when it's at the ground?
When it's at ground level, what's the height?
Wouldn't it be 0 feet?
That's right, 0. The height is 0 when the projectile hits the ground, so set S equal to 0.
And the initial velocity is still 112. Now, how do we solve this?
I don't like that negative there in front of the t squared.
You know what? So I'm going to just do this. Write it as 16t squared minus 112t equals 0. Okay?
I think I'd pull the same trick I did a moment ago.
Yeah.
There's common factor of what? 16, that's right.
So divide straight through by 16, and we have the equation t squared minus 7t equals 0. And how do we factor that?
It's not a trinomial.
Well,
maybe we have a common factor, though, in both of those terms. What's the common factor?
We call this factoring out a variable. We could
factoring out a common factor. We're reversing the distributive property. Just like up here, we're reversing the FOIL method. Here, we're reversing the distributive property. T times what gives you t squared?
T
minus t times what gives you 7t?
7.
Notice if you distributed the t, you'd get back t squared minus 7t.
So just like in part A, it looks like we're going to have two answers. The first answer is the trivial answer. T equals 0. Well,
that's before the projectile is launched.
Yeah.
0 seconds before it's launched,
it was on the ground.
It was sitting on the ground, so the height was 0. So that's not when it returned to the ground. How long did it take for that thing to go on its flight and come back to Earth? Setting t minus 7 equal to 0, we get t equals 7.
Now, is this hours, minutes, or what?
Seconds.
Seconds. So it's a very short trip.
It's like a little bottle rocket. That's what I think of it as. It returns to Earth. The projectile returns to the ground after
7 seconds. Any questions there?
2. Okay, let's move on.
Moving on to the next
2.
one. If each of the sides of a square are lengthed by 6 centimeters, I think that means increased. Lengthened. Lengthened. That makes sense. Okay. I read length. That's not a word, I don't think. If each of the sides of a square are lengthened by 6 centimeters, the area becomes 121 square centimeters. Find the length of a side of the original square. So we want the length of the side of the original square.
Well,
so
let's start off by reviewing the
area of a
square.
Okay.
In a square, the 2 sides are equal, and to find the area, that's x times x. You multiply the 2
times
sides.
Height, length times width, whatever you want to call it. You multiply the 2 dimensions to get the area.
Now, it said on the problem, if the 2 sides are lengthened by
6 centimeters.
6 centimeters.
So the 2 sides are being lengthened. That means they're increasing the length by 6 centimeters. So whatever the original length of the side was, you're adding 6 to both of those. So if the dimensions are lengthened by 6 centimeters, what did they say? The area becomes 121 square centimeters.
Oh, okay, so here, the x plus 6 times x plus 6 equals, what did you say, 121?
121.
Well,
before we go on and solve this equation, realize you started off with a square. The sides, you don't know their length, so we said x and x. They tell you to increase the length by 6 centimeters, so we added 6, added 6. We know to find the area of a rectangle or a square, we multiply the 2 dimensions, length times width. So the new rectangle, or the new square, has a side length of x plus 6. So x plus 6 times x plus 6. They tell us the area is 121 square centimeters. Any questions there? Because at this point, it's just a square root problem. A square root method. Y'all remember the square root method? To use the square root method, you have to have a quantity squared on one side and a number by itself on the other side.
you know what? Let me write it the way they saw it when they were doing the square root
When
method.
you were doing the square root method, I think you had the variable on the left side. Equality is reflexive. You can just flip-flop both sides if you want to.
So we're going to, what cancels out a square?
A square root, that's right. So you drop the square on the left, and you just have x plus 6. But you're going to pick up a square root, that's right, but it's more than just a square root. You need the plus minus as well.
Well, at this point, I'm not, what's the square root of 121? Y'all need to punch that in your calculator?
No, they know it's 11, but I'm just going to do this just to show them, in case they had a number that was really messy and they didn't know the square root. They can punch it into their calculator and get 11. So we have an x plus 6 is equal to a positive or negative 11.
Well, in theoretically, it's plus or minus, but we don't want a negative length on these. We don't need to worry about that negative 11, because if we do, we're going to wind up with a negative
17.
Yeah, so to just write x plus 6 equals positive 11.
This is one of those times where if you forget the plus minus, you'll still be okay.
What would you do to get that by itself? Just subtract 6?
That's right.
So,
11 minus 6. So that original square was 5 by 5. 5 centimeters by 5 centimeters.
Right little C in there, so they'll
Oh, yes.
realize that it's centimeters. Yes. So the length of a side of the original square is 5, and look what they're going to do here. We got to choose centimeters. The length is in terms of centimeters.
Area is in terms of
Square
squares.
meters. Right. The
Oh,
was that it?
Yeah,
I thought there was
it.
more than.
Okay.
There's only one part here. Okay. I'm sorry. I was sort of surprised. I thought there was another part to this. So,
Now, problem number 3 is very similar to that.
the width of the top of a workbench is 5 meters greater than, no, the length of the top of a workbench is 5 meters greater than the width. The area is 84 square meters. Find the length and the width of the workbench. Let's see. So the length is longer than the width. The width is the smaller side. They're told the length is 5 meters more. I like to make the shorter side the unknown. So let's switch over to the paper.
Right
Tony was
here,
writing. Oh, look at
I
that.
just wanted to review the area of a rectangle formula. It's the square is just a special case of this, length times width, but with a square they're the same amount here and here. On this problem number 3 that we have, our rectangle.
Okay, what's your through drawing? I'm going to switch back so they can read the problem again. Notice how many times we go back and reread the problem as we're synthesizing this information they've given us. The length is 5 meters greater than the width. So we don't know anything about the width. I would say that width is the unknown.
I'll call that width x. So the length is 5 centimeters?
5 meters.
5 meters.
It's a workbench.
Oh, a workbench. So that would be x plus 5. Notice how the length is longer than the width. It's 5 meters longer than the width. So what were we told the area is?
Let's go back. No, they told us the area. Where is it? The area is 84 square meters. Remember, area is in terms of square units.
So this is a nice little review of some geometry.
It is. I'm really enjoying it.
Okay, so
I'm really enjoying it.
width.
I don't know how the students are enjoying it or not, but I'm just having a great time. We know length times width. Multiply those two dimensions, and that's going to give us the area, which was, that's right, 84.
Length times width equals area. Now let's distribute this x right here. So we have x squared plus 5x. So we have a quadratic equation.
I think we better get it set equal to 0. Because whether you're going to solve it by factoring or the quadratic formula, you need 0 on one side, and we want a positive leading coefficient on the other side. And this one has a positive leading coefficient. What is that positive leading coefficient?
Well, it's not
I see someone with a finger.
Understood 1.
Okay, yes, it's a positive 1, understood 1. It's a simple trinomial. Shouldn't be too bad to factor. We'll write our parentheses.
And what numbers multiply together to give 84? I know 2 divides into it, but I think you've got it.
12 and 7
times 7 would give us 84.
And notice their difference is 5. 12 minus 7 is 5. Isn't that what we need? That middle term to be? Now wait a minute. What about the signs inside the parentheses? The last sign's a minus, so you have, 1 plus and 1 minus. Play around with it in your head. What should go here? The plus or minus to get back that plus 5x.
You would need a positive 12 and a minus 7.
I agree. That's going to be a 12x minus 7x. That gives us the positive 5x.
Now, set each one of these to 0. And when dealing with applications, there's a lot of times you can't have negative answers. Would it make sense for the width of this rectangle to be
A negative 12.
negative 12?
Is that, can you measure the width of a rectangle and it be negative 12? It can't be negative anything. The width has to be a non-negative number. So cross that out.
You almost got a width needs to be a positive
I know.
number. It
I
couldn't-
know.
If the width were 0, it wouldn't be a rectangle. It'd just be a little line. segment.
Mm-hmm. Line segment.
Now move this over, and we get x equals
7. And remember the units are meters in this case.
Okay.
And so the width of the workbench is 7 meters.
Let's
What's
type
the
that.
length going to be?
Oh,
I don't know which one they're asking for first.
well, if we put a 7 in here for x, so this is the width, and the length is 5 meters more, x plus 5, so 12 meters. Let's see what they're asking for.
Honestly. The width, the width of the workbench. You're right. That's what they wanted.
7.
No, it's 5. Oh, no, it's 7. Oops. 7, and I pull down the units.
Meters.
That's right.
Area is in square meters. Length and width are just
The units themselves. And the length of the workbench, 7 plus 5, that was 12 meters. Oh,
okay, good.
any questions there? Okay. Number 4. As Tony writes down the pertinent information on the paper, I'll read the problem to you. The formula S equals 16t squared is used to approximate the distance S in feet that an object falls freely from rest in t seconds. Okay, let me reread that. The formula S equals 16t squared is used to approximate the distance S. So capital S is the distance in feet that an object falls freely from rest in t seconds. So you're up on top of a building or something, and you're dropping an object down. The height of a building is 1,163 feet. How long will it take for an object to fall from the top?
So we're going to plug in that 1,163, but what are we going to plug it in for?
Where is that going to go? Is that going to be T or S? There are 2 letters here in this formula.
But T says seconds, S says feet. What do we have?
You're going to replace the S with 163 feet. Hold on, let me switch to the paper. Tony's been summarizing this stuff. S is the distance in feet. T is time in seconds since you released that object from the top of the building. And the height of the building is 1,163 feet. It's a pretty tall building, isn't it?
So if I plug 1,163 in for S, oops. Let's see, we need to solve for T now.
I think this is tailor-made for the square root method. Now, those of you that like the T by itself on the other, the square term by itself on the other side, we could just rewrite it. Just flip-flop the sides. 16t squared equals 1,163. You think they like that? Or do
Let's
you
just leave it like that.
Okay.
Now.
If you're going to use the square root method, what's being squared here? Is 16 being squared?
No.
No, just the t. So get rid of that 16 by doing what?
Do we subtract or divide?
Okay, you divide. That's correct. Uh-oh. I suppose it's too much to ask for, but no, it's not going to go in evenly. 1163, an odd number.
Ooh.
Oh.
Okay,
well,
wait, now let's read the problem and see how are they
How do they
telling
want
us
us to, do they want us to round the answers or something?
Type an
Type an
integer.
integer or a decimal rounded to the nearest tenth.
Well, only type an integer if it's an
Integer.
You don't get to
This
choose.
thing is not going to be an integer. You see that? So we'll just
Let me just go ahead. I'm going to write down t squared equals, what's that
wait
number?
a minute.
72.6875. Now,
normally we would use a positive or negative when we use the square root method, but would it make sense for that time to be negative?
this cannot be negative. Okay, I'm going to go as far as to say it's got to be positive.
The time, the length that ball is falling has to be a positive number. So we can drop if you're one of those people that forgets the plus minus all the time, then this is one of those times where you'll be okay. I see someone laughing back there. Yeah, some of you always forget that plus minus when using the square root method, and in this case, you'll be okay. So let's take the square root of that number. Let's see, here's my square root key right there. It's in orange. So I'll go second. There's the square root. Oh, I'm sorry about that. And then I want the previous answer. So, well, I could have typed the 72.6875 all over again.
Notice how we didn't round anything until the very end.
Do not round until the very end.
So we're told to round to the nearest tenth.
So is that going to stay in 8.5 or is it going to go up to an 8.6?
Well, the digit is, after the 5 is a 5 or larger, you round up. Otherwise, you just drop it.
I think we're going to drop it.
Okay.
So that object fell from the top of that building for 8.5 seconds before it hit the ground. It's an extremely tall building, okay? Okay, let's switch over here. And we're going to type in 8.5 seconds. I lost where's the mouse? Oh. There. Okay.
Problem number 5. Oh, this is the first of a few problems. Let's see, it said, dealing with this idea of a horizon. At the height of h meters, you can see v kilometers to the horizon.
So if you're up h meters in the air, you can see a distance of v kilometers. These numbers are related by the formula v equals 3.5 times the square root of h. How far can you see to the horizon through an airplane window at a height or altitude of 7,000 meters? So let's see. V is how far you can see to the horizon, okay? That's the distance you're seeing. H is the height when you're looking, okay? How high up are you?
V, so I'm writing down the problem. V, or the formula, 3.5
times the square root of h.
How
far can you see to the horizon through an airplane window at a height of 7,000? Let me ask you something. Is that 7,000 meters, is that V or H? It's a height. That's right. It's a height, so it goes where H is. I'm going to switch to the paper.
Well, wait, I'm trying to decide what to write for the V.
V is the
V kilometers to the horizon.
Distance to the horizon.
Okay. Distance to the horizon.
Yeah, that's good. Hold on.
Okay. So you're at 7,000 meters. Well, this is not a building that you're looking out to the horizon.
Maybe we should make a note that V is in terms of kilometers.
Yes, kilometers.
The height is just in terms of meters. Okay, so we want to know how far can we see if we're on an airplane 7,000 meters in the air looking at the horizon. Let's replace that H with 7,000. So
that into your calculator.
3.5 times, oh wait, I need to clear that off.
Yeah.
It looks so messy when I got to clear off all those giblets that are left over from the,
no.
wait a minute. 3.5 square root 7,000. Always, if they opens a parenthesis, the calculator, I close it. It's just the old programmer in me. I don't want those.
How are we told to round?
I don't know. We better look and see.
292.8.
Oh, round to the nearest whole number.
Okay. So if we round to the nearest whole number, do we leave it at 292 or make it 293?
What did Tony say? If it's the next digit is a 5 or more, you boost up. So that 292 is going to become
293.
Those wavy equals are his way of saying this is just an approximation, a rounded value. 293 kilometers. Just think, way up there in that airplane, this person can sure see a long distance. I wonder if that formula always works, or if it's just a random formula that was made up. I bet it's just a random formula that made up.
I don't know. I'll have to see. I think the next one.
Number 6.
But they're using that same formula in number 6.
Oh, you're right. A steeplejack can see 56 kilometers to the horizon from the top of a building. A steeplejack? I don't know what that is. These numbers are related by the equation V equals 3.5 times the square root of h, where V is the distance in kilometers from the steeplejack's eyes to the horizon, and h is the height in meters of the steeplejack's eyes. I suppose a steeplejack must be maybe it's someone that works on, building tall buildings. Yeah, let's see. Oh, it's a person who climbs tall structures, such as chimneys and steeples, in order to carry out repairs. Okay, I didn't know that.
Yeah.
Thank you, Google. Okay. So this person can see 56 kilometers to the horizon from the top of a building. We're using that same formula. We know V is the distance they see
In kilometers.
and h is the height that the person is in meters.
And so
That 56, I think we know that 56, is that going to become an H or a V? At 56, it's kilometers.
So it's gotta be V.
Okay.
So plug 56 in for V.
V.
I'll do this right. 56 equals 3.5
Times the square root of h. And we're trying to find the height. How high is that steeplejack if he can see 56 kilometers? Well, I know one thing. It's not 7,000 meters, because if that were the case, he'd see a lot further. So
Let's solve for h. The first thing we'll do is divide both sides by 3.5. Okay.
So we have
you might punch that into your calculator.
56 divided by 3.5 equals, hey, it's 16.
16. Okay.
Oh, I wasn't expecting that.
So we have 16 equals square root of h. So this is all, how do we get rid of the square root? What's going to cancel that out?
Okay, you square both sides.
So let's square both sides. And we're going to get h equals, what's 16 times 16?
Isn't it 256?
Is it 256?
You can verify it with your calculator.
And this is an h. That's in meters. So 256 meters.
That's still a pretty tall. He's still at a 20-story building.
Working.
That's
256 meters.
That's just something I couldn't do. I don't think I could work up like that. I'd start looking down and get dizzy, and next thing you know, I'd be falling. I'd be careful there, okay? Any questions there? It just keeps getting easier and easier, doesn't it? Okay.
Oh, is this the same question? Or no, it's a different question.
There's no steeplejack here.
Oh, no.
at a height of h meters, you can see v kilometers to the horizon. These numbers are related. It's that same formula. I think we need to go to the Republic of Texas, and I'll ask him, how high up are we? So I can then use the formula to see how far I can see to the horizon, provided there's not a marine layer out there. That's a big, yeah. Oh, wait a minute. So here's the formula. A person can see 364 kilometers to the distance from an airplane window. I don't know how this person knows they're seeing 364 kilometers, but okay. They have some little device they're measuring. They're seeing 364 kilometers to the horizon. How high up is the airplane?
Hopefully by now you've got the hang of it. That 364.
Is that going to be V or is that going to be H? It's kilometers, so
which one of them has kilometers?
I think it's V. That's right.
That's right.
So let me switch to the paper. Oh, wait.
I think this one's going to be very similar to the number 6,
yeah,
right?
I think so.
Plug 364 in for V. And then go through those same steps. Oh, I don't think it's going to be...
I don't know that it's going to work out.
Perfect square.
364 divided by 3.5. Oh,
wow. Okay.
It's an integer. It's not a perfect square, but it's an integer at least. Okay.
Well, I don't think it needs to be a perfect square.
Oh, you're right. It is.
What was it? 104?
104. You're right.
Equals the square root of h. Now, how do I cancel out that square root?
Do what you did up here. Square both sides.
So what's 104 squared?
It looks like this person is at a height, the plane is at a height of 10,816 meters. Any questions there? Oh, I better punch in the answer. I don't know. So y'all will know that we're telling y'all correctly. Any questions there?
Let's see, is number 8, does it have more? No, new formula.
New formula.
Okay.
I love the way we're coming up with these and winding up with little quadratic equations we have to solve.
Yeah, there's a lot of applications you can solve just with just the algebra we've done so far. The equation R.
The formula R equals 2 times the square root of 5L. Both of those are under the radical. The 5 and the capital L can be used to approximate the speed R in miles per hour.
Wait, R is speed?
Speed in miles per hour, mph. And of a car that has left skids of length L in feet. So they're driving, they hit the brake, they start skidding. So L is the length of the skid marks.
The length of the skid mark is, I just wrote, if you want to show, I just wrote length is L, length and feet.
It's
That's the length of the skid mark.
I just feel better if you wrote skid mark right there.
Skid mark.
Okay.
So at a given speed, you can find the length of the skid mark by solving for L.
Or what crime scene investigators do is they measure the length of the skid mark to determine how fast the person was going, say leading up to a wreck or something. So let's keep going.
How far will a car skid at 60 miles an hour? 60. I'm going to write 60 miles per hour here.
Which one is that? Is that R or L? Which one's the miles per hour?
Well,
the R, that's
the R is miles. So we're going to plug a 60 in for R. So I'd have 60 equals 2 times the square root of 5L.
So this is a square root equation. When I'm solving a square root equation, well, we want to get that radical expression by itself. So what do you think I'm going to do with that 2?
I'll give you a hint. Are we going to subtract or divide? Divide?
Yes.
Undoing the multiplication, you divide, so you have 30 equals the square root of 5L. Now we need to get rid of that square root. What are we going to do?
What cancels out a square root?
Remember solving those square root equations? They were a lot messier than this, but it's still the same idea. You square to get rid of that square root.
So the square root and the square cancel out.
And we know that 30 squared is 900.
30 times 30. And then equals 5L.
What do we need to do to find the length of that skid mark? I agree. Divide by 5. So that skid mark they're leaving is 180 feet long.
180 feet.
Okay. So
So
come
60
back.
miles an hour. Then your skid mark.
180 feet. Okay. Any questions there? Okay, number 9. Lisa, an experienced shipping clerk, can fill a certain order in 7 hours. Tom, a new clerk, needs 10 hours to do the same job. Working together, how long will it take them to fill the order? It's always sort of funny when people do this problem incorrectly by averaging the two numbers. Wait a minute, that's going to take 8.5 hours if they're working together. Tom needs to sit down and let Lisa do the job in only 7 hours.
Sometimes people add them together and they'll say 17 hours. I'm like, no.
If that's just the answer, working together, we can conclude something. If Lisa can do the job in 7 hours by herself, and Tom can do the job by himself for 10 hours, if Tom is helping Lisa, do you agree that working together, it should take under 7 hours? If it takes over 7 hours, then Tom needs to, sit down and let Lisa do the entire job. We have a little formula here that Tony's going to mention. You want to talk about your little formula for these working together problems?
Now, if there's 2 people working, and it takes, what was it, Lisa got, 7 hours?
Lisa, it takes her 7 hours. 7 hours alone.
And Tom is slower.
He's new because he's new. He doesn't know that he's not familiar with the system yet. So
Tom, it takes him 10 hours working alone. You see, if it takes 7 hours, then Lisa can do 1/7 of the job in an hour's time.
So 1 over time alone 1. Lisa can do 1/7 of the job in an hour.
And that's what we're going to calculate.
Plus, how much of the job can Tom do in 1 hour? It takes him 10 hours to do the whole job. He can do 1/10 of the job. That's what that 1 over time alone 2 means. Here's how much Lisa does in an hour. Here's how much Tom does in an hour.
But now they're working together,
so that's the amount they can do in 1 hour working together. So how much time together? We don't know. That's the X. That's the thing we're uncertain of. I would even write out X is the time required with them working together. I think students want me to leave. I think they like it better when I'm not here telling you. I'd write out this too.
Yeah. There. Okay. That's a good thing to do. Now, what we've done in the past when we solved equations like this, we just multiply through by 70x and get
the
rid
least
of
common denominator.
But here, I want to show a way of doing this that's a little clever, okay? Rather than multiply through by 70x to get rid of the fractions. Let's use our calculator to add 1 over 7 and 1 over 10. And you might think, oh, wow, wait, it's going to give us a decimal number. But if you have a decimal number on a calculator like this and you want to convert it to a fraction, it'll do it.
This is true for an 83 or an 84 if you're using a TI model, and I think most of y'all are. If you have a decimal and you want to convert to a fraction, you click Math, And you'll notice.
And do you see that number 1? It says
arrow
fraction. So you're going to convert to a fraction. So you need that one thing to activate that 1 there. Well, just say enter, and then it's taking the answer, converting it to a fraction. Say enter again. So math enter. If you want to convert a fraction, a decimal to a fraction, math enter. We could have gotten this just by going, okay, write that with the denominator of 70. 1 times 10, that's 10 70ths plus 7 multiplied above and below by 7. 7 over 70. That's how they got that 17 70ths.
Now, if two fractions are equal, then their reciprocals are equal. So what I'm going to do now is going to look strange, but I don't want to know. I want to know the answer for x, not 1 over x. If I flip that, I would just get x over 1, which is x. So I'm just using the statement that
if two fractions are equal, their reciprocals are equal. If you flip this side, flipping 1 over x, you'd get an x over 1, which is just x. Flipping 17 over 70, it becomes 70 over 17. So it takes Lisa and Tom working together 70 over 17 hours.
I don't know how we're told to punch this in, but
it seems like
punch that into 70 divided by 17. What's the decimal number? No, 70 divided by 17.
That's what you said. I wrote the wrong thing. 70 divided. I typed the wrong thing.
So working together, it takes just a little over 4 hours.
Is that a sensible answer?
Yes.
Lisa can do it in 7 hours. Tom, it takes 10 hours. Working together, it should be less than 7 hours.
That's a sensible answer.
That is a sensible answer.
Mm-hmm.
4 hours. Let's see, what do they say? How do they want us to type this here?
It says, I just type in 70 over 17.
I'm going to just type in 70 over 17. 70 over 17.
They don't want you to type a decimal because it didn't tell you how to round.
Yes. They say simplify, but they don't tell you how to round, so don't use a decimal. But if you're curious, 70 over 17, that's a little over 4 hours. So it took them a little over 4 hours working together to do the job. Any questions there? When you're doing the working together problems, it's important to remember 1 over time alone 1 plus 1 over time alone 2 equals 1 over time together.
And you know what, Tim? I'm going to go ahead and do something a new teacher mistake.
Oh, a classic new teacher mistake.
If you didn't like what we did here, use the calculator, get this, and flip it. You could do what we've done in class. Multiply straight through by 70x.
7 and 10 have no common factors other than just 1. So the least common multiple would be 70. 7 times 10, and then you stick on the variable. Multiply 3 by the least common denominator. 70 divided by 7 gives a 10x, plus 70 divided by 10 gives you a 7. You still have that x, equals, multiply by 70x over here, the x's cancel. 1 times 70 gives you 70.
I don't know, maybe that's how I should have done it. I just like to add them up and flip.
I do too.
That's how we're going to do number 10, if number 10 is like this.
Yeah. Is number 10 a working together problem? Let's see. I guess it is. A swimming pool can be filled in 15 hours if water enters through a pipe alone, or in 22 hours if water enters through a hose alone. Okay, so the pipe is bigger than the hose. If water's entering through both the pipe and the hose, how long will it take to fill the pool? Okay, so the pipe alone, it takes 15 hours. The hose alone takes 22 hours. Let's see. Oh, I don't want to pull up.
There, so the pipe alone takes 15 hours. The hose alone takes 22 hours. Working together, it's X hours.
So,
I'd write hours right there.
1 over time alone 1.
So that's the time alone for the first item, plus
1 over
time alone 2, that's the second item, equals
1 over
together.
If you want to get the common denominator and multiply through by, what is that going to be? Probably 15 times 22.
Yeah, I think 15.
330x?
330x.
Yeah.
So the least common denominator would be 330x, but I think I'm going to do it the way we did earlier. Let's say 1 divided by 15 plus 1 divided by 22. That gives me, I have that decimal number. Remember, convert to a fraction. So you go math, enter, 37 over 330 equals 1 over x. If two fractions are equal, their reciprocals are equal, so flip the 1 over x to give you x over 1 equals, flip the 37 over 330 to give you
330 over 37.
And if you're just wondering, how long is that? Is it a sensible answer? Because working together, the answer must be less than what? 15. If it takes more than 15 hours, then that hose needs to be turned off and they just, well, I did it wrong. That's not right. We're taking, it's 330 divided by 37. That's it. Look, it's almost 9 hours. Working together. Say that you have your new pool and you're filling it right now. You want to have a pool party tonight. Well, it's going to take you about 9 hours using both the pipe and the hose to fill it.
I sort of like these problems better when it's just machinery like this. Because, when maybe Lisa and Tom, maybe they start having a good time at work goofing off, in which case maybe it did take longer than that 4 hours.
I know there are things I can do shorter than if I'm just sitting doing it myself than if you and I are together like this right now. If I weren't here today, then I think you'd already be through with the assignment. So wait a minute. Let me come back over here.
I don't think it said to enter a decimal. No. Integer, fraction, or mixed number. Just type in the fraction. 330 over
330 over 37.
But if you wanted to type a mixed number, which we never do, I hardly ever use, but that's it, right? Okay, well, that was the last problem. So thank you for watching the video. I hope you're having a good day whenever or wherever it is that you're watching this. Right now.
Okay. Any questions? No, okay. I see people packing up. Hold on then. Let me stop the recording. Let me stop the recording.
Oh,
yeah, that's right.